Well, hello, everyone. I'm Nate, as you just heard. So I'm the founder at Cloudsec.ai, and we help companies that are either building agentic systems or rolling out security programs where they're concerned about it and they're looking for help. Also, exec in residence over at Scale Venture Partners, and then I work with Ken at the Cloud Security Alliance on the AI technology and risk group. So we're writing a lot of papers, trying to help provide guidance for building secure agentic systems. So we have one coming out in a month. And there's one from last year on authorization best practices. So for those of you interested in building, a good one to check out. So I want to start with this because when we talk about security, there's all the stuff that you know as security practitioners. But at the end of the day, it really just comes down to a prioritization problem. Anyone, you could take an engineer, you could take a random person, and you can ask them to make a system more secure. They can probably come up with something to do that's going to make the system more secure. What sets you apart from being in security is you have a lot of depth. You have a lot of background in understanding what's the actual risk, what's the impact, what's the likelihood, and you're able to use that to make more informed decisions. And that's important because you can make any sort of system more secure, but it's what you're doing with the limited resources you have. Are you making the most impact with that? And that's why I want to make sure we're talking through what are you worried about when it comes to AI-based systems, agentic systems, because we need to make sure people are focusing on the right things. Otherwise, you can be going through the motions, you can be securing systems, but was that the right decision? Was that the place you should have been placing your bets? So, I wanted to see quickly from people in the audience, how many of you are worried about companies training on your data? Is that something that comes up? Yeah, all right, lots of hands, sure. Let's see here. Model poisoning. Somebody getting into the data, they implant some stuff, they can trigger it later. All right, perfect. Well, we'll start with these two. So for the concern about training on your data, I will let this image first soak in. Not so easy to get a generated image of Sam Altman doing squats with data, but there he is, training on your data. When it comes to training on your data, I mean, realistically, the companies like OpenAI, like Anthropic, you have contracts with them. It's in the MSA that they're not going to train on your data. Any other company, conceivably they could, but also very easy to put it in your MSA. Don't train on our data. You can tell them whatever retention you want. You usually have a limited amount of time to be vetting these companies, to be trying to figure out what can go wrong. And I see a lot of companies spending inordinate amounts of time talking about training on our data. And realistically, there's a lot of other ways that you're much more likely to have a leak or a breach through using AI or agentic systems. So just want to call that one out. Poison models. Also much easier, but it turns out it's not easy to get an image generated of humans doing self-harm. So that took a little bit of extra prompt engineering to get the nice drink of polonium by the model. Again, probably not in the top 20 risks that you need to worry about. And the reason I say that is there's a lot of things that would have to happen for model poisoning to work. For one, the company has to be using their own models that they're building and training. Conceivably, you could poison OpenAI's models and try to trigger it later, but at the end of the day, this is a really complex attack to pull off. You need to know what the training set is of whoever's building the model. You need to implant stuff. You need to know how the model is going to be used within an agent, and then you need to set a trigger that's going to do something. And all of that has to happen knowing that they're probably going to swap models in 6 months anyway. So if you're an attacker, it's also a prioritization problem. You have resources like your time. And are you really going to spend your time doing that when you can still send an email over to John, he's going to click on it, and you get access to the systems? It's probably not going to happen. So while it is a risk, especially in certain regulated industries, maybe you want to be thinking about this. If you're targeted by state-sponsored actors, sure. But again, the 99% of other companies, this realistically isn't something you should be worried too much about. And the reason that I wanted to raise all of this is making sure people are asking smart questions is probably the single biggest thing you can do to influence security at your own vendors and with your own engineers. Like, how many people here are the ones building the systems? Your engineers and kind of hands-on keyboard? Okay, it's like a third. And the rest of you, you're evaluating systems, either your own internally built stuff or vendors? Yeah. So these questions are the biggest thing you can do to influence how these systems are built. When you're kind of in the pre-sales motions, you're evaluating systems. If you're spending time asking about training on your models, the people on the other side, they're happy to spend 15 of the 30 or 45 minutes you're looking into the system talking about how they're not training on models. You could be asking a lot of other questions that are going to be pushing them much harder to improve their security. And so it's really important that you use those resources, because you can have an outsized impact by asking your own engineers, how are you dealing with X or Y, instead of focusing on some of the other things that maybe you hear about a lot but aren't necessarily going to be the largest impact items. So when we talk about things to worry about, and I'll go through these, but prompt injection is the big one. I know it was talked about earlier today in both talks. This is really the root of why Agentic AI has unique problems. So prompt injection sort of is the jumping off point. It's the start of the chain for a lot of these attacks that are going to abuse authorization privileges. It's for a lot of the attacks where you saw data exfiltration. Automatic tool usage doesn't require a lot of imagination to see how that can go wrong. Same with AI writing code. We're going to see a lot more of this in the future as people start figuring out how to get a handle on that. So everybody knows prompt injection. We've established that already. How many people know about indirect prompt injection or have been looking into that? Okay, about half. So this is really kind of the threat when you're talking about agentic systems, because prompt injection itself is, ignore this, do this other thing instead. That's the user or somebody trying to override the system prompt. What makes it so much more dangerous when you talk about agentic systems now is you're pulling context in from other places. You have tool use that's able to access the wiki, it's able to query your Slack, whatever it might be. It's pulling all this context into the context window. And just because it's from your internal systems, it's from your database, your Slack, whatever, that does not mean it's safe in any way, shape, or form. We saw earlier all the ways people can hide text with making non-printing characters. You could put white on white text where no one's going to see it. All of this gets loaded and seen by the LLM. And the difference here between direct and indirect is now you're not trying to override the system prompt where you're telling it to ignore some instructions in lieu of doing this other thing. You can think about when you use ChatGPT, you might say, hey, do this thing. You paste in like a doc. But then at the end, you might be like, on second thought, do this other thing. It's all just user instructions and data together. The control and data plane are mixed when it comes to how LLMs operate. And so with indirect, it's now not trying to override a system prompt. It just looks like something the user might have been asking as well. It's much harder to sort out, much harder to filter. And when you get to like the RAG and memory poisoning, if you have an agent that's writing back to a database where you're doing RAG and doing retrieval augmented generation, pulling it back in, if you have long-term memory, these attacks can now be persistent. So it's kind of terrifying, actually, because as mentioned earlier, we don't really have a great way to prevent this. We have layered defenses. We can get some 98%, 99% good, and probably you need to layer a few of those. Really, we want to make it difficult so that an attacker isn't going to use their limited resources on this because there's easier targets out there. So anytime you have content that's being pulled into a context window and that context window is used by agents to decide what to do, that should be setting off alarm bells. If you're working with vendors, you want to be asking much more, how are they mitigating this? If you're working with your developers, you want to make sure, how are you thinking about this? What can go wrong? Kicking that off is part of some of the threat modeling exercises. So authorization, this is another one, because as we were talking about earlier, there's no pattern for how to build these things. People are kind of doing all sorts of different things, seeing what sticks, seeing what solves the problem in the best way. So things to think about, like, are you using service accounts? Does the agent have its own identity that it works under? Maybe that works, but maybe that's too much permission. Do you have it act as the user? So maybe it has whatever permissions the user does, so it can't expand over that and kind of leak stuff to the user. That could work as well. You probably want to be thinking of both because, again, with indirect prompt injection, you could be overriding the user's concerns. And if you're acting as the user, you can do things the user doesn't want. So if I ask Gemini to summarize my email, but it also has the ability to delete my email and it's indirect injected, you can see where things go wrong. So setting up, thinking about least privilege when it comes to service accounts, layered with what the user's allowed to do. I mean, it's all of these layered defenses that you want to think about as you're putting this stuff together. And the big thing is never trust anything in the context window for authorization decisions. anything in there can be injected, it can be tricked. You'd never, ever, ever want to use that for making a decision on, is this allowed or is this not allowed? You need deterministic controls outside of the context window to make those decisions. This is a Cloud Security Alliance paper we worked on last year, was entirely on this. It was about using deterministic means, and really, if I can summarize the 20-page paper, it's never trust the context window. All right. Data exfiltration. This is another one that I think people should be thinking through. I won't go into a ton of depth because we saw earlier all the cool examples of where you can do this. If the system can send files, you have tools that allow that. Clearly, that's probably something to be worried about. But it's the things like rendering image links, where once the LLM has access to some data, it's in the context window. There's nothing to say deterministically that you're not able to trick the LLM into rendering an image link. And when it pulls the image link, it can append that string at the end, which is whatever data was in the context window. It can leak back out. So again, anything that goes in the context window, you have to almost consider that that's on the edge of leaking if you have things like this. If you're able to render markdown links, you can, again, indirect inject an LLM to say, hey, user, click this link for more information. And if the user clicks it, that link has that data to be exfiltrated. It goes into the server logs of whoever the attacker is. So it's these subtle things that people aren't necessarily going to think about. It's really worth making sure your developers know about it. Or if you have vendors, you want to ask, are these things possible? Do you render image links? Does the LLM generate image links? And if it does, how do you prevent things from leaking out that way? Automatic tool usage. I think we probably won't talk a ton about this. Clearly, if you have an LLM able to start using tools without human in the loop, things can go wrong. Not only because it's been indirectly injected, but also just things go wrong with LLMs. And so anytime you have a large selection of tools, it's very powerful. You can solve a lot of problems. But at the same time, those tools can be misused. And the more combinations of those there are, the more your attack surface is, and the harder it is to think about what can go wrong. And it very quickly becomes unmanageable as to understanding how can this system go wrong. So anything you can do to really sandbox things down into smaller chunks that you can manage, that you can reason through, is going to be really helpful. AI writing code. I think probably not many places are doing this now. I know there's a few shops that are. It's something that I think we're going to see much more and more, because it really gives you that ultimate flexibility to solve any problem you want to think of. As LLMs get better at writing code, you can now just hand it any problem, and if it doesn't have a tool to do it, it can build its own tool, solve the problem. Obviously, that poses lots of other problems. If your AI is able to dynamically run code and has access to all the information it needs, a million things can go wrong. So some of the just high-level things to think of: how do you sandbox it? How do you limit capabilities? How do you keep it from importing libraries randomly that might give it access to, say, the underlying OS? What are the security and trust boundaries? So how do you keep that thing from getting access to other systems that you didn't intend? Because if there's data leaking in, again, anytime it's in the context window, and particularly if you have the ability to write code, it's going to be much, much easier to leak in ways that you've never thought through. And that's where I think anybody that's thinking of doing this, it's really going to be important to start small. Make sure you work with the team and make it an experimentation, a learning exercise, because no team is going to be able to just jump in and do this really well. You're going to have to fumble around. You're going to have to find stuff that breaks. You want to do that in a very controlled fashion, rather than having people do this in a big rush where they need to kind of make this thing live for next quarter's release. Great, that's avocado toast, in case anyone was wondering. Training and education, we really just talked about, you want to make it safe to not know, because you want to have a culture where people can say they don't know, where they can ask for help, because then others can get in, because others probably have the same questions. And then you can make it where this is something that it's part of our culture, that we are experimenting. That's what we do. We fail, we learn, we're continuously improving. That's something everybody says, continuous improvement. Everybody knows it's important, but with AI, with LLMs moving as fast as they are, it's much more important than ever before. So thinking through how you share learnings, how do you incentivize experimentation, all of those become much, much more important. But at the end of the day, when we talk about AI software and what you need to think about, it's still just software. So don't get overblown with all of these concerns. They're very real, they're very unique, but you still have to think about all the basics. Like, how are they finding vulnerabilities? Do they have a bounty program? Do you have one? Because regardless of if it exists or not, or if you even know it exists, it does exist. So how are you handling authorization? How are you finding vulnerabilities ahead of time? Are you training people? How many engineers have access to the data? I mean, these are things that exist as problems, and it's really easy to forget about them because we're kind of staring at the shiny new AI thing. But it's really important to not forget about all of these things. And that is my talk with 20 seconds left.